I'm Chris with OCO Labs, and in this video we're going to be performing an extraction with the SuperC tabletop CO2 extractor. There are a number of materials which can be processed via CO2, and today we're going to be running hops. A couple of notes about your material. Regardless of the type, you should be using dry material. Wet, fresh, or fresh frozen material will all give you undesirable outputs in your extract, such as chlorophyll. Another thing to note is particle size. If you're using a dry, leafy product like hops, you should be able to crunch it by hand to get it down to a small enough size. If the material you're using is thicker or is otherwise denser, you may want to consider grinding it with a coffee grinder or a milling machine. Somewhere between 1 and 3 millimeters is an ideal particle size. Once our material is prepped, we can load the chamber. I've already loaded this chamber, and what I did was I took my ground material, working in sections, filling, and then packing. We want an even and firmly packed bed of material so that as the CO2 flows through the system, it's contacting as much surface area as possible. Before you begin your extraction, you should lubricate your system, as shown in a previous video. If you're unsure how to saturate the oiling felts inside your compressor, please revisit that other video. In the process of supercritical CO2 extraction, there are two variables we are primarily concerned with. Those are pressure and temperature. A given pressure or temperature combination will affect the way the CO2 can extract a given compound. If you know the material you're trying to extract, we should be able to find those parameters. In the case of the hops that we're going to run, we've selected 2800 psi and 53 degrees Celsius. This is a great starting point for any material that's high in resin, as opposed to a material that's high in terpenes. Terpenes, being a lighter compound, extract better at a lower pressure and temperature. To set the temperature on our SuperC extractor, we'll want to access the temp controller at the back below the fan. Press and hold S until F1 appears, release S, then repress and continue to hold it. While holding S, we can steer the temperature up or down using the arrow keys. We're going to raise our temperature to 53 for this hop extraction. Now that we reached our setting, we release S, click the power button once to lock it in. If you ever need to check what the setting is, you can press the up key and it'll show what you have set the system to. Once we've set our temperature, we can then begin increasing the pressure to our desired pressure setting. To do this, we want to close our valve. Once the pin is snug, that's enough. We only need the gas to be stopped. Anything tighter than that can damage your valve. Once that's closed, we can open our tank and listen that the back check valves are sealing. That will give us an 800 psi bulk feed from the tank, from which we can then increase pressure. The best way to do this is to start by flipping the switch to the middle position and allow the heaters to start heating the chamber. The sound of the fan means you're getting power to both the fan and the heater. Once your temperature reading is at least 31 degrees, we can then turn on the motor and continue progressing all the way up to, in our case, 2800 psi.
Once you reach your desired pressure, we can engage the autopilot. Pressing the red button on the autopilot control box will set your pressure value, and the autopilot will hold this value until you change it using the toggle switch.
In addition to our pressure and temperature, we also selected a runtime. Our runtime was 45 minutes, as that's what we've found is optimal for hops. Some materials will run longer. If you're unsure of how long to run your material and are unable to find research on it, we recommend you start at 45 minutes and increase your runtimes by 15 minutes until you find your peak. This is because CO2 functions on a diminishing returns curve. So over time, you'll get less extract per minute. Once you reach your limit in either quantity or quality, that's when you can call it done. Once you reach the end of your runtime, you can depressurize your system. This is done by turning off your CO2 tank, turning off the motor, and the autopilot. Finally, you can release the pressure at your valve until the gauge reads 0. At this point, you can collect your extract. Now that our system is depressurized, we can begin recovering the extract from our collection vessel. If you're using a material like hops, which has a thick resinous output, I recommend scraping the jar with something like a thin-edged silicone spatula. If you're doing a light fraction extraction on compounds such as terpenes, you should be able to pour that material or use a pipette to remove it from the jar. Now we can take a look at some of what we extracted. Between runs, you'll want to clean your system. The level at which you clean it will depend on the frequency at which we've been running it, as well as the needs of your project. Regardless, all of the cleaning happens downstream of this fitting. The chamber which held your material and the valve through which your extract passed are the contaminated parts which should be cleaned. Cleaning the chamber is really pretty simple. Start by removing the exhausted material. Once the exhausted material has been removed, we can take a paper towel soaked in rubbing alcohol and pass it through. Pay particular attention to keeping the threads clean, as it'll make your life a lot easier. The other component which will always need to be cleaned is the valve. At minimum, between every run you should clean this filter. This centered bronze filter is the only filter in the system, and in every run it will build up the extract and plant material. While the plant material can be scraped off the face, the extract will need to be dissolved. So taking a wrench and removing this fitting, I recommend you soak it in rubbing alcohol to get a thorough clean. If you need a more thorough cleaning, due to issues of material change or cross-contamination, you'll need to disassemble the valve. And in addition to removing the filter, that will require you to wrench this fitting out, as well as removing these two mounting bolts. By taking these components apart, you'll have access to all of the individual components inside, which can then be cleaned thoroughly. Regardless of if you need to do this every run, you should do this every 10 or so runs. If you'd like to learn more about the SuperC extractor and its upgrades, be sure to check out our full series of videos, including maintenance, unboxing assembly, and profiles on all of our products. Any other questions can be directed to us via email at info@ocolabs.com. This is Chris with OCO Labs. Thanks for watching.